Hello, and thank you for listening to this brief talk on seismic and blast engineering. I'm AdamFox from Mason UK. Mason Industries is a long-time contributor to ASHRAE, and primarily we're responsible for controlling surface vibration and thermal movement, but our projects often have a seismic and blast criteria. Seismic and blast are intrinsically related. Surfaces placed in these environments have to accept the forces which result from rapid displacement in all directions. Primarily, the difference between the two is duration. A blast is a single displacement of structure that rapidly damps. Seismic events can continue for a period of time, which increases the chance of damage and force amplification. Anchorage of plant, piping and ducting to structure must be done in a way that's considerate to the nature of the equipment and the building in which it is placed. Often the need for anchorage is safety, to prevent high mass objects shifting or falling from height. Preventing excessive movement can also dramatically reduce cost of repair and the time taken to bring a building back up to speed after an event, especially if flooding from cracked pipes is prevented. Correct technique also allows cost savings, as isolators can be used to reduce forces seen by equipment, meaning expensive ruggedized equipment is not required. There are two methods of calculation, static and dynamic. Static is simplistic but suited to statically mounted cases where equipment is rigidly bolted. The nature of the forces will dictate the extent of anchorage required to prevent overturning, pivoting, swinging, etc. It's important to note that anchorage into structure is only as good as the structure itself, which also needs to be reviewed. Spring and rubber isolators are introduced when there's a need for vibration control and or to cushion equipment against seismic and blast forces. The intent being that equipment sees less force than the structure, less displacement than the structure, and a reduced acceleration. The introduction of resilient element means that resonant conditions have to be quantified. Most events are broadband with energy content across the spectrum. This, coupled with the duration of event, mean the motion and response of an isolated system has to be derived in all major axes. This is done through the use of a dynamic model. The dynamic analysis outputs forces and displacement at each support point and each attachment point to a pipe or duct. Understanding of forces allows correct selection of anchors and snubbers, and the displacement the correct selection of flexible connectors which can accept the movement without failure. If equipment is to remain functional following a seismic or blast event, acceleration forces must be kept below acceptable fragility levels. If equipment manufacturers carried out this assessment, then the dynamic analysis can often be a paper exercise. However, if there is uncertainty or a piece of equipment which has not been previously certified, then a physical test can be carried out on a shaker table. Since 2000, the International Building Code has required seismic certification of all equipment required for the continued operation in an essential facility. Shaker table testing is accepted as the only method of certifying the functionality of active or energized components. Testing of equipment on isolators and snubbers is the only way to obtain certification for equipment that will need to be vibration isolated. Crucially, equipment will remain functional after an event. Whether statically or dynamically determined, it's important that all elements are considered part of a single engineered system. Some examples are shown on this slide, but in summary is that each element that contributes to a load path needs to be correctly engineered. Anchorage into a concrete plinth requires the plinth to be similarly well anchored to structure. Ducts and pipes hung from above act as natural pendulums. Nesting and clash analysis can be complex. If a run is considered in isolation of others, it might not be buildable on site. With a holistic approach, cost and time can be saved when all considered together. It's unlikely that, especially in countries like the UK, contractors will be familiar with these processes and correct installation of equipment. Having an experienced supplier on board from the outset is important, and equally, site enforcement of the installation allowed for. Small errors like oversized holes, tension cables or pneumatic spring mounts can result in failure. Thank you for listening. Please don't hesitate to get in contact if you'd like to discuss further.